Before we get started, Jason, there's a happy hour happening after we're going somewhere.
Yeah, we're going to do the, just totally, casual, but after the recording from the Mac Admins podcast, we're going to go down to the Precinct bar down the street, and we got our Brex cards. I'll put it on the tab, put it on Fleet, so drinks on Fleet.
And then we're also doing a GitOps workshop tomorrow as well, and also one in Sydney next week. So a lot of what we're talking about today is GitOps focused. So if you want to join that, there's a couple seats left, so we'd love to have you. So this talk has sort of evolved. I've done it a few times, but when I was doing it for XWorld, I wanted to take the opportunity and the extra time to extend and show some of the functionality of using Santa with Fleet. So really the purpose of this talk is to show potential other options to manage your Santa config. And of course, there's no right or wrong way to do this. Each organization has their own unique problems and solutions. So I'm just going to show you kind of what this looks like using GitOps and being able to manage your devices, what they can run, what they can't run, and doing that all in code. So let's get started. My name's Harrison, or Harry, here at Fleet. I'm a solutions consultant, former CPE, former security engineer, also worked corporate side for a while. Before that, I worked in restaurants all over Europe and the US, so kind of an eclectic background. And then just very into climbing, yoga, and your classic kind of tinkering that every IT guy likes to do. So what is Fleet? We're a open source cross-platform MDM. We're built on top of OS Query. We support a bunch of robust orchestration capabilities that you'll see throughout the presentation. We also do software deployment, vulnerability management, and last but not least, we're an API-first platform, so you can manage all of your devices in code. And what is Santa? Santa's one of the things we're talking about today. A really key security tool for macOS. It's basically a binary and file authorization system for macOS. And you leverage a rule set of allow lists, deny lists, and you're setting those based off of some application identifiers like CD hash, team ID, things like that. And traditionally, a deployment has a dedicated sync server tied to it. And that's kind of a lot of what we're talking about today is replacing that sync server using your current MDM. This is what the end users see when they go to open up a restricted application. So you see here we've blocked WhatsApp, and this is presented to the end user. They can grab some more information around it. All this messaging is custom for your organization. So let's talk about that sync server. It primarily serves three purposes: to distribute your allow and deny rules across all of your hosts. You can also use it to collect execution events and blocked binary reports. And then you can use it to manage your core functionality of the app. So any of the messaging you want to present to your end users, branding, things like that. And it's traditionally just a URL that's pointed in a plist. And there's kind of three main deployment options today. So you have Moroz. All of these are great options. But we have Moroz, which is our golang-based server where you have the hard-coded rules. We also have Rudolph, which is a serverless sync service built on Amazon's API gateway. And then you have Zentral, where you're managing all of your rules and your configuration in Terraform. But the downside is running any of these solutions may incur additional infrastructure costs, add additional upkeep, and you potentially might have to adopt a configuration language that your team might not be familiar with. So for example, Terraform. And that's kind of the goal of this talk, like I mentioned at the beginning, is to show an alternate way to deploy and manage your sync server right in your MDM. And I also am going to show you some expanded capabilities of Santa kind of to tell a better story about your environment. So this is kind of the three parts that we're going to talk about today. We have Fleet as the MDM, the top there. We have our GitOps approach to device management. And then we also have, of course, Santa, where we're completing the ecosystem. So the why of what we're talking about. So primarily, configuration is code. So you're storing all of your rules and all of your configuration in Git. You have easy deployment across all of your hosts. You have the streamlined rule distribution. So when you're using GitOps, you have an automatic deployment of the most recent configuration and your rules. And then you can also use the power of OS Query to collect, aggregate, ship, and visualize the data, which I'll show you further on. So kind of pulling this apart under the hood, we have this separated in two components. And what you see here is kind of a declarative approach to device management in Fleet. We have a group of devices that are going to receive this configuration. And then we assign the base config, the Santa base config, and then we apply a static rules plist on top of that. So we layer it on top. And that looks something like this. This is, again, your core configuration of the Santa app. So things like what mode you're running, any of the messaging you want to present to your end users, your machine owner mapping, things like that all go in here. And these are things that rarely change. And if you were to change them, it would have more sort of thorough testing and things like that. So we kind of just lay this down as our base config. And then over the top, we lay our static rules plist file. And then those get merged together to create one static Santa config. The great thing about these is they're written in XML or traditional mobile config where all of your Apple admins are already familiar with. And the key here is that this is kind of where we're managing leveraging most of the GitOps capabilities. So you'll see when we kind of go through all of the different automation capabilities, they're going to be manipulating this file here. And here's just another kind of closer look at the static rule set. So here's blocking a couple different applications based on some different identifiers. What's important to call out here is that when you deploy it this way, the configuration is immutable. And so even with sudo, it can't be changed. So if you have some savvy users that want to skirt a rule, developers, they can't do it. And of course, since you've deployed this via MDM, the plist can't be removed or tampered with. So if a user was to go and change a rule or try to change some Santa configs, they're met with a notification like this. All right, so now let's look at some of the automation. So in Fleet, we have some built-in Santa tables. Again, Fleet is built on top of OS Query. So you're using simple SQL syntax to query the devices. So for example, you can see here, we're just doing a select star or select all from Santa denied table, which will then show at the per host level which applications were attempted to be executed. But we also have other tables for Santa as well. For example, we have the Santa status table, which is really handy to gather information around your status or your configuration of Santa. So for example, what mode you're running, number of rules that are set, any sort of watchdog information. And this is super helpful to gather on a regular interval and then ship that to a SIM to sort of monitor for changes and look at kind of the state changes over a period of time. And so with these tables and the data that comes with them, there's tons of automation that you can leverage. So for example, here in our internal instance of Fleet, which we call dog food, we have a workflow where we're sending the Santa denied logs out to a webhook. We're using an automation platform called Tines. So we send the results of the Santa denied queries to a Tines endpoint, which we can then action on and bring the alerts to where our security team is already working, which is Slack. So you can see here, for example, when we have this alert is fired, we have a bot that is going to present us with a couple different options. You have the ability to open up a GitHub issue, which is where we kind of put all of our tickets. You could make this like a Jira ticket or things like that. But you could also create and initiate a security incident. So let's say one of the processes that was blocked was potentially maybe an indicator of compromise. You can use that to kind of launch your security incident. And just a little side around Tines, it's super flexible. It's very simple to kind of tie all these things together. You can kind of just see here, we're using just a few of the basic cards to accomplish this automation. And so what that looks like is, let's say this alert came in and you said, hey, I want to actually approve this application, or I want to have my security team look at it in more detail. So we're going to create this GitHub issue. And it's going to take all the information from that scheduled query, what app was blocked, why, any of the information around the identifiers. So here it's blocked on the team ID. And we can say, hey, like, let's say we wanted to allow this application in our environment. We would work off of this ticket here. And of course, it's labeled and tagged appropriately. So my team can triage it and we can quickly unblock our users. Or perhaps you use that automation to turn it right into a pull request. So for example, we had that open issue button, but you could also just trigger off a pull request where we're using all that information from the Santa denied query. And then you can make a pull request or have a bot make a pull request, and it's going to go right to your team. They hit approve, and then the GitOps workflow will run. The rule will be applied to all your devices almost instantaneously. So then you have that GitOps methodology advantage where you know who approved what app and why, which you'll see. I have a small demo at the end where you kind of see where this all comes together. And then lastly, there's the data visualization piece. So for example, you can ship the results of all of your Santa tables, Santa denied, any of your rules, status, things like that. You can ship it out to, for example, a Splunk or a visualization tool. Here's just an example of a dashboard showing apps that were attempted to open over a period of time. So here's kind of a demonstration of it all coming together. I wasn't feeling confident in the demo gods today, so I pre-recorded this, and I'll kind of talk through each of the components as we're going through. So we're going to start out. We have a VM here. And this is basically just an app, an environment that has a couple rules applied to it. And we're using the Santa CTL binary to get some information around this application. So Telegram. When you run this, you'll see primarily at the top there, the rules shows as none. This application can be opened, and you can see Telegram opens. Now we're going to go back to that static rules file. We're going to open it up in our text editor. Here, for example, we're just going to add a block to block the Telegram app. You can kind of see we're just going to copy an existing block, and we're going to modify some of the keys, right? We're going to block it on the team ID, which is the most broad that you can do. We're going to set the rule type, say, hey, we're blocking on that team ID, add a comment up there at the top. And then we're going to go through our traditional sort of code process, right? I'm going to add it, I'm going to commit it, and I'm going to push it up to the branch that I'm working out of, which will then show something like this. We're going to open up a pull request for my team to review. Say, hey, we want to add this new rule to our environment. Add your comments. Hey, this looks good. You can see the file that was changed, so we know exactly what's going to be impacted. And then we can go ahead and squash that, merge it, which will then trigger off our CI/CD pipeline. What this is doing under the hood is a lot of different things. If you wanted to know more around kind of the finer details of what's happening here, we can talk offline. But basically, we're compiling a new configuration profile that has that new rule. And then you can see now it's deployed to our devices, and Telegram has that blocked rule signature at the top there. And then our users try to open the application, they're granted with something like this, showing that they can't be loaded. And then within a few minutes, we'll see this alert come in where we can triage that. And then if we wanted to kind of take action, you can do that there. So why this way? Why would you kind of adopt the GitOps and Santa approach? It's simplified architecture. You have no technical overhead. You're not managing an additional configuration server or paying for additional infrastructure. And you get to adopt the DevOps methodologies, so you're integrating with your existing sort of CI/CD pipeline. You can easily see who pushed what rule, like when and why. You're gaining operational efficiency, so it becomes super quick and easy to push a config to thousands of devices almost instantaneously. And with that comes the scalability. So you can deploy this on large or small fleets with very little overhead. I think that's all I had. I went through it a little quicker than I thought. This is just a QR code to my LinkedIn. If you had any questions around the implementation, I would love to do a longer session and kind of show people, some more detail around it. And I just want to give a shout out to all of my colleagues at Fleet that were allow us to kind of work on this, particularly Alan. We built some of these tables together, and it was really fun to be able to kind of show this. So thanks for stopping by. And if you have any questions, let me know.
Hey guys, sorry, regular questions person has disappeared, so I'll take over for a second. Does anyone have any actual questions they want to start with?
Hey, do you know if Santa has a way to log app usage? So like if you haven't denied everything, but you're in a bit of a discovery phase of like what you want to block and unblock.
Yeah, so when you do a Santa deployment, you run it in monitor mode, which is just going to collect everything that was executed. You can also use a table for that. So I showed the Santa denied table, but you could use the Santa allowed, and you're going to get everything that executed. And then from there, you can kind of pick apart what was ran, add that to your allow list, and then you switch it into block mode from there.
Harry, great talk. I got a two-part question for you. The last one's a bit of a silly question, but the first part is the team ID. Mm-hmm. What's the mechanism that's used there? Is that like the publisher of the app or something like that? Is that okay?
Yeah, I was going to put the slide in, but you can basically there's a wide range. You can block on team ID, which is the most broad. This is like the developer that's provided by Apple, or you can block all the way down to like a hash, so a certain build of an application. And then there's some other things in between that you can block on. So there's a bit different range of how broad or specific you want to get with a block.
And then the second part of the question is for the Santa block dialogue that shows up for the user, can I also play a jump scare audio file?
I haven't tried, but it would be cool to try that.
Awesome. Any other questions? On over here.
I was just wondering, how are you populating your list of all of the apps? Is that something that's coming out of OS Query or Fleet, or is it still quite a manual process?
Like the apps that we're allowing and blocking? So we ran Santa allowed first and just kind of see in monitor mode, like what was being executed. And then from there, you can kind of, use some queries to pull that all in, visualize, count, sort, things like that, and then put it into lockdown mode. And then you can have a defined list of allowed, and then everything else is blocked.
And are you still sticking with Team ID or vendor certs? Would you like to do hashes instead, or?
For the most part, Team ID we do just because it's most broad. We also do a lot of testing around it, so not everyone has it like in production. But depending, like if you had a particular build that's something like Zoom or Chrome that this version is exploitable, we want to block it. That's where you use something like this, the hash, and you would block it like that from loading.
Cool. Thank you.
And you get all that information from the Santa CTL binary. Where you can run it against an application. It'll give you all the information, different certs, CD hash, all that. And then you can use those keys to block on.
Okay, thank you very much, Harrison.
Yeah, of course.
Wonderful.